I'm Kevin Cleary. I'm at Children's National, and I've been working in the area for about 30 years in medical devices and robotics. And it's great to see the explosion of interest now at Hamlin again. It's great to be back after the pandemic, that we can do this in person. It wasn't really the same by Zoom. So feel free to interrupt me. I think I can fit within the time fine. So if you disagree with what I'm saying, or you want to interrupt, or if you want to shout out, go ahead, since you're in the front row right here. We can make it a little bit lively, and hopefully everyone can see it. And it's great here with the fan. You should have stayed on this side right here. You got the fan right here. So anyway, nothing to disclose. This is our hospital in Washington, D.C. You shouldn't take anything I say. It's legal advice right here. Again, I'll give you some background.
I want to trade down from the previous quote too.
Yeah, that's right. And your mileage may vary, but the idea here is to share, experiences. And I'm not sure that I'm the best person to give this talk with some of the people here as well too in open source, but I'll give you some thoughts. So here's our hospital. We're right in the middle of Washington, D.C. So as hospitals go, we're typically measured by beds. We're a 300-bed hospital. We're the major hospital for the Washington, D.C. area. So Washington, D.C. is not that big, about 600,000 people. But the suburbs, a lot of the counties have 1 million. So the whole area is about 6 million in the metropolitan area. And the model is the hospital is downtown, and they have clinics all around the suburbs, where then if people have major issues, they get referred to the hospital. Three-part mission, so we do research, care, and education. So we have we're a pediatric training center as well. Technically, we are the pediatrics department of George Washington University, but we're a separate nonprofit. And now we're actually up to about 7,000 employees, so we're one of the major employees in the city too. So when they set up our institute, which was 13 years ago, they had gotten a big gift from United Arab Emirates, and I was at the adult hospital at Georgetown University. My kids were still in high school, so I didn't want to move then, but I was able to go across town. And the idea was to set up an innovation institute within the hospital. So we're on the top floor of the hospital, which of course makes it very easy to work with the clinicians. So there were 4 parts to the institute: pain medicine, immunology, bioengineering, and personalized medicine. The other 3 were already there and were biology based, but our institute was really a technology institute. So even then, the surge of technology was already started, and now with the consumer marketplace bringing all this technology, I kind of feel we don't need to develop that much new technology, but we need to adapt it to medical care. And with that comes also you need to understand the regulatory environment. So we have some very nice research space on the top of the hospital here. And, we basically want to enable next generation of minimally invasive procedures through technology developments, which you've all seen at the conference here too. And we are a resource for the hospital as well. So with that, let's talk a little bit about why use open source software, a little bit of historical review, talk a little bit about how this applies to image gravity navigation, medical robotics, and then I'll have a little bit of a summary. Okay, I think this will be familiar to everybody in the room. The idea, of course, is to avoid reinventing the wheel. And some of this is taken by a blog post. Some of you may know Bill Hoffman from Kitware was involved when they first set up Kitware, and we all said, back then, can they really make money and can they survive this way? But just like Peter, like we survived for a long time, they survived, right? At first, I thought they were going to go to a product mix, but that never really happened. So But anyway, I think it's very fair to say without open source software, a lot of the technology advances we have witnessed, it would not happen right here. So, the AI boom is not fueled by closed software, but open source tools right here. There was something here that even the self-driving cars are based on a lot of open source software as well. Now, whether that's been a success yet, you might debate right here too. So this is just a nice blog post. So I think everybody would agree that we can't really build the tools that we do and work in the field that we do without open source software, or we probably won't be competitive with our peers who are using open source software. So Kitware, again, to me is my classic business model for open source. Can you really make money from open source? When we talk about the commercialization. So 1998, so they've been around for a while. So, more than 25 years right now. And of course, you talked about the Insight ITK and BTK and the Visible Human Project when all that was starting right here. So that was all developed and supported by NIH. So I actually voted for funding in your first announcement there, because to me, funding makes it all possible. I realize the other stuff is important, but we even say in research labs, maybe even like your personal life, if your funding is okay, everything else you can kind of figure out, you know, but if you don't have money to run your projects and hire your postdocs and staff, then it's tough. So they had developed the Insight Toolkit, and then things were more C++ based back in those days. I kind of joke my first programming class, I hate to say when, 1978, was Fortran on punch cards. So we've come a long way since then, right here. And the joke with punch cards is you would have decks you carry around and you would slap someone's decks and then they have to restack their cards right here. Anyway, now we're a lot better, right? So we developed the CMake software tool right here that they like. Somebody from Kitware was telling me that, or somebody, I can't remember, they don't really like CMake. It's just kind of awkward, but a lot of people use it to put builds together and things like that. But also we're cross-platform, you know, so I think that's really cool nowadays too, as well too. You know, and of course, Kitware has been heavily involved with 3D Slicer since the very beginning days. So in terms of image-guided navigation, way back in the early days, we got some money when we were still at Georgetown University for something called the Image-Guided Surgical Toolkit. And this was working with a guy named Luis Ibanez at Kitware at the time, who later went on to Google as well. That was before AndyNet came into the picture right here. And, you know, the basic components, so, you know, again, 20 years back, you had a tracker, localizer, you know, and this was just starting to be published and developed. And the idea was, again, instead of everybody writing their own code, you know, why don't you just have open source code? And we actually published a little book with it. And we went to SPI Medical Imaging and we brought our book. People still seem to like hard copy right then to have a little book to come back. You know, and that, you know, and of course, this was all supplemented by 3D Slicer too, when actually Slicer came out as well. But, you know, if you look back in a field, you know, I know it's easy to look back at the latest literature, but I think sometimes, you know, particularly for the younger researchers, it is good to look back at the history, you know, that things came from somewhere. And most good ideas people have had before, but maybe the technology was not quite ready to implement. So that was based on localizer technology. And again, probably 20 years ago, when Northern Digital first bought this electromagnetic tracking from a European manufacturer, it actually didn't come out of Northern Digital. You know, they now run their operations near Lake Constance in Germany as well for electromagnetic tracking. You know, the idea that you could have non-line of sight tracking enabled some things too as well. The drawback with non-line of sight tracking is you had to put small sensor coils in your instrument tip as well in order to track them, but that made possible some advances. And so we did a little project way back about 2005 at Georgetown. This is electromagnetically tracked biopsy in the CT scanner with the Northern Digital, with the open source software, and we were able to do a few patients. You see the big fiducial grid. Now this stuff is a lot better. You know, it's almost a commodity too as well. But it's amazing what we can do with these tools. But I think the basic ideas are still the same. So then, and I'm sorry if I didn't mention your toolkit too as well. You can sort this out. Fortunately, I think I put a slide in for Peter. I didn't even know he was going to be here. So that's what we said. You know, make sure you cover who's going to be in your audience. You know, or if you submit a paper or an NIH proposal, if you think those reviewers are going to be in your panel, make sure you cite their work right here too. Anyway, this is MITK. So this was out of Heidelberg. Some people may remember Peter Meinzner was in Heidelberg, and yeah, I guess Lena was still there at that time. I kept saying when she was again. Say that right here. But anyway, you know, this was the medical interaction toolkit right here, and again, free interactive software for medical imaging. So these things became popular both in the U.S. and Europe. So you know, I would say 20, 25 years, maybe roots in open source software. You know, again, if you look at the original Da Vinci, 1999, there's a Da Vinci came out too as well. So, okay, when were you born? No, I'm joking. Sorry. Okay, we don't need to go into that. Okay, and then this was ITK. So you mentioned ITK as well. You know, so ITK was a very popular toolkit for image processing right here. You know, and then again, this was the blog post from Kitware as well. That's worth reading. But again, even back then, the idea was always that it was going to be open source, that it was going to be cross-platform. You could contribute back, but you weren't required to contribute back. You could use the software for commercialization, but as Ina said, you know, then it's up to you to get the regulatory approval. But there's plenty of open source software using things that have been FDA approved. And as the first speaker mentioned, FDA really looks at your process as to how do you control the testing. They don't go into your lines of code and say, why in this line did you use this instead of this right here? So. Okay, so we don't need to say too much about 3D Slicer. I think people are very familiar with 3D Slicer, you know, and I mean, really, Ron Kikinis and Steve Piper and the people who were down since the early days, you know, have continued to promote this. And, you know, to Ron's credit, he still seems to be able to find funding for it. So again, that's why I mentioned funding. It's very tough to sustain these packages over time. And I think if you do want quality software, you do need people to sustain, to maintain them, to have the user community, to help out, moderate forums, answer questions. But again, 3D Slicer was a software application for visualization and analysis right here. Supported many data sets now, of course, has now grown to where there's an incredible number of libraries with Slicer. So Slicer Plus Toolkit, Slicer for these things, Slicer Salt, I think, is now out for finite element analysis. So you can take these tools and you can build things, but it's not completely for the faint of heart. Again, if you were a Fortran programmer like me, who then learned to program in the original C, and I did my PhD on wireframe graphics because we couldn't do solid models at the time. And I'm more of a mechanical engineer than a coder. It's pretty tough to take all these packages and put them together. So one option is to hire smart people, you know, who work with them and do that too as well. The other option is to do training. But I do think that in order to, it's certainly gotten a lot better because the documentation, I think, for this software has gotten better and there's a bigger community around it. But I do think you need some programming skills, and now things tend to be more Python based. So, you know, I encourage again the young people to take programming classes, even if you're mechanical engineering. You know, the idea that AI again is just going to take over all our code generation for us, and you're going to have any idea of understanding what it did, I think it's not a reality. So I think you still need to learn how to code and to put together these packages, and then, you know, it's good to participate in the user meetings in the community so that you can get help when you leverage things. You know, again, in the old days when we wrote code, and actually I was talking with Bob Webster last night about his company Virtuoso. I said, "Are you using open source now?" He said, "No, we wrote all the code themselves now." Was that for regulatory reasons? Was that because they had a library they had developed over time? Or is it when you actually write the code yourself, you do understand all the nuances, you know, and when something goes wrong, you know, so sometimes when you use open source and something goes wrong, you know, you're kind of like, well, what library is it in? It wasn't my library. I didn't really understand it. So it can be a challenging. And although modern computers are so fast that I don't think the computational power is an issue anymore, when you have layers and layers of software, it complicates things sometimes. So I think simplified architecture. So I think those are still challenges for the community. How can we build open source tools and build incredibly complex systems? And I'm going to show an example here of one next, but still maintain kind of quality control, understanding of the system where everything is not a black box. So, you know, I mean, I think the trend in AI, if you want to use AI in medicine, is towards explainable AI. So how can you say, you know, so maybe we should also think in open source software, do we have explainable open source? You know, do we have traceable open source, reliable open source? And I think we're certainly getting there. So anyway, just my thoughts. Okay, so 3D Slicer again, you know, all features available, extensible, very good product development platform. And again, no restrictions right here. So again, the fact is you can use these, people do, then it's up to the software distributor to meet the FDA requirements. And as our first speaker said, it's a lot of paperwork right here. So, you know, that's one thing. Okay. All right. So now we're going to switch and we're going to talk a little bit about medical robotics and give the example right here. This is, you know, so thank goodness, Peter, I put this slide in right here too. Move this back because sometimes you get lucky right here too as well. You know, so again, Peter can obviously talk about this much better than me. But again, I think this was a great set of somewhat open software. Maybe you say a little open hardware. Yeah, as well. You know, it's both. And so I think that's another trend, open hardware and open software to do things again that were not imaginable, right, when we were in graduate school starting out, you know. So, you know, again, what people can do with 3D printing, with Arduinos, with open source, you know, big defense manufacturers couldn't even do when I was in graduate school. You know, those technologies just didn't exist. So now we have to think about how do we apply them to benefit medicine. So anyway, telerobotics platform that provides access to all levels of control, you know, employs the FPGA, and I think the fact you guys built the hardware and all that was very cool too. You know, and now you're using later generation.
SI. I have a poster.
You have a poster, okay. Yeah. Is it still up today?
No, it's from today.
Oh, okay. All right. Well, don't bias him if they vote for posters, but go see the poster. Yeah, no, we'll have to declare conflict of interesting. So, you know, but anyway, this is old, right? How many people are
That's over 40.
over 40? Yeah, yeah. So incredible. You know, so this has been a great research committee, and I give not only credit to you guys, but to Intuitive, right? And maybe it was Simon who really fought for it most, or other people in Intuitive now. I don't know.
Simon really pushed it.
Yeah,
Yeah.
right, right. And have any other companies followed suit now? I guess they don't have as much retired hardware.
No.
Everybody else charges. So okay, yeah, okay, sounds good. All right, so, you know, and again, you have a whole research community, you have the challenge here to have and things like that. And I think that's incredibly powerful, because you look at what you can do as a group versus what a sole researcher can do, there's no comparison. And I don't think you can be competitive in this field now unless you are participating in some things. You know, again, the era of the sole researcher working in this garage, probably over, okay? All right, this is Ross. Many of you know Ross, and I'm sure many of you know Ross much better than me, too, right here. You know, which again is a standard platform. And when I looked at this, and I hate to keep picking on you, Peter, but you know, this is like a foundation now, right? That runs Ross or something like that. Or, yeah. So, you know, I mean, again, it seems like there's business models at least, you know, because they must have some paid staff with that, you know, entity right here to do this. So, you know, they're at least, so I think that some of the questions and maybe the first survey you put up about how do we sustain things, you know, how do we create sustainable open source. You know, this is, but again, to me, when I look at things like Ross, again, you know, I did go through robotics and do kinematics, and my PhD was on, you know, to look into these platforms and understand the nuances of all the libraries and how do you use them, and downloading them into things, you know, it still takes a little bit of knowledge and experience. Okay, all right, so we're going to switch gears completely. Okay, and now I'm just going to talk about a demonstration project and an example of why you would use open source. And so this is actually a project with Axel Krieger at Hopkins, and this is on robotic renal tumor surgery. There's a new funding agency in the U.S. called ARPA-H. That's ARPA for Health. Many years ago, we had DARPA. Some people will claim that Rick Satava started some things with that, later led to Intuitive Surgical out of DARPA, Defense Advanced Research Projects Agency. Then it went to ARPA in the UH, which was kind of the civilian side of that agency. And now they have ARPA-H. But for researchers, again, they have some money. You know, so we look for some money, and they're proposing various calls, and so we got some money. They nicknamed it this project SART, Supervised Autonomous Robotic Renal Tumor Surgery. So the question is, you know, do you think in the future we'll have fully autonomous robotic surgery? You know, good question for the conference. And you know, most of the people I speak to say, for one, it's a little bit of a dream. You know, just like when is the self-driving car really going to come? And then two, you know, does the medical profession really want that? Does the patient want that? I think the patient wants a medical doctor to explain to them what they're doing. I think we'll have partial autonomy where the robot can help with tasks. The other thing, if you have full autonomy, how will surgeons train? Then when the robot or something breaks down, what do the surgeons do, right? Your neurosurgery training, is that it?
Many years.
Many years down the road. So in a future life, when you turn 40 or whatever, you'll find out, you know, the long pathway. But anyway, you know, so will there be a robot in your future? You know, maybe, but I think you would still like to be in control. You know, and I think that's the way to really think about what robots will do. So, you know, partial autonomy, we could call it. So anyway, this was to develop a robotic system capable of providing supervised autonomous renal tumor resection. And we asked for a lot of money in many years. They gave us 1 year. The person kept saying, you'll understand why I only gave you 1 year. I'm like, well, I really don't understand, but I'll take the money and, you know, hopefully apply for more later on. So we did it on kidney phantoms, and we'll show these pictures of these very cool kidney phantoms that Dr. Ghazi at Hopkins has now been developing too, as well, with Axel and others. So these are all the smiling faces right here too as well. So Axel, Dr. Ghazi here. So with ARPA-H, it's a little different for those of you who run projects. It's a contract, not a grant. So with a grant, like an NIH grant, you do your best faith effort. Every year you report, and I've never had my report not accepted. So, you know, as long as you're making some progress with NIH, you generally get the next round of money, and grants can typically be 4 or 5 years for the big grants. With ARPA-H, right now, it's 1 year. It's a contract with milestones. We have quarterly milestones that we have to hit. And those, anybody work in industry here? Yeah, so those who work in industry. When I work in industry, we have very specific Gantt charts. You know, academic researchers like, yeah, we'll do the best we can. industry. And so we have Gantt charts with milestones we have to hit. Fortunately, we chose the milestones where I'm pretty sure we'll hit them as well, but it's just a little different. So the background is, I think, some of you may know, but for those who are not clinicians, the idea when you have to do partial nephrectomy, which is a kidney removal, a tumor, is to make sure you get good tumor margins because you don't want recurrence, but also you want to spare as much healthy kidney as you can so they'll have good function. So called nephron sparing surgery right here. And so when you look at the kidney and things, in the real world, if you're using either da Vinci or laparoscopic, it's not always so easy to distinguish where the tumor is and trying to make the mental map from the preoperative images to the intraoperative images here. But it's critical to minimize the amount. And then also, you have to clamp the kidney off so you don't have too much blood loss during the surgery. And this is called the warm ischemia time. So as soon as you clamp, they would typically say it would be nice to do your removal within 20 to 30 minutes so you can then unclamp and then maintain blood flow so to not compromise the organ. So I don't know if this is going to play because it didn't necessarily play before. Oh, it is. Oh, okay. Okay. Maybe okay. Okay. So this, okay. So anyway, this was just kind of simulated, with the idea of here, you're clamping the vessels right here. And of course, in the real world, it doesn't come out. It's not quite as nice a picture like this right here. And then this is a picture of the intraoperative scene. And when I see this, even having watched a lot, I still always need the surgeon to explain to me exactly what part I'm looking at right here. So sometimes they use intraoperative ultrasound. So Intuitive has a drop-in probe that they can use, and they can kind of make the ultrasound map. But it's not like they're ultrasounding with one hand and cutting with the other. They're doing the ultrasound, they're looking and say, okay, here I am, here's where I want to go. Now let me go back and get our margins. So a critical part of this procedure is helping them get good tumor margins. Okay, so this was kind of a workflow. So one thing when you want to analyze surgical procedures from an engineering standpoint, you may want to develop a surgical workflow here, right here. So preoperative scan, place the trocars, you insufflate the abdomen, create a working space, you expose things, So a lot of times at the beginning, when they're coming around, they're kind of freeing up the kidney, they're kind of getting their surgical exposure. Then here's where they do the clip of the artery and vein. And then this is the tumor resection. Finally, you close right here and you check. So the main things we can help on, if we think of partial autonomy, what are the critical steps of the procedure and what could we help with? And we think in this case, one is of course surgical planning. And then surgical execution. So if you can think about it, what you want to have is you want to have a good plan. You want to be able to execute that plan. And then you really want to be able to verify that that plan was executed before you close. Those are really the steps we're trying to help with. So this is the one slide I borrowed from Axel's paper and also from the group from Germany. You're on this too? No, that's the other Laura. That's the other Laura. Oh, sorry, Laura. Yep, I just saw the Laura name. Yeah. But anyway, that's what, if you can join the meeting next week, that's what they're talking about. So, to me, I don't know how much of this is built with open source, but I would say most all of it is built with open source. So the visualization, the finite element analysis, the things like that too as well. And I think this is a preprint from their IROS paper right here too, which I heard is going to be like in Abu Dhabi or the UAE this fall. But all this is built on open source. And if you had to develop all of this yourself, you really couldn't do it. So the reason we were able to propose this to ARPA and do this as a one-year demonstration project is, for one, Axel had already done a lot of work in this area too as well. But now you're based upon open source packages. So it's really about defining the software architecture and how do you put these packages together to do things as well. And then, of course, now that you're using this to drive a robot, when things go wrong, how do you troubleshoot as well? And how do you track all that stuff? So I think those are some of the challenges. So these are these really cool kidney phantoms. So I think you're right. I think I loaded the PDF and I should have loaded the PowerPoint with the videos. But anyway, you get the idea. So what Dr. Ghazi has been doing, and he came to Hopkins recently, I think he was in Rochester or Buffalo before then, is building patient-specific models right here. So you take a patient scan, you do your segmentation, and again, almost all this can be automated, and then you actually make molds. So you're not 3D printing the model, but you're 3D printing a mold, which you can then make the phantom from. They can add vasculature. They have a pretty good way of checking that the properties, the mechanical properties, are pretty similar right here. And then, these are fantastic for training. I think what Dr. Ghazi would eventually like to do is even replace cadaver training with these type of training models too in the future right here. So, and then finally, this project will conclude in a demonstration right here, in Axel's lab. And, again, if you haven't been to the Hopkins lab lately, I was there, you were there when the ARPA-H people came. It's really impressive, with the different demonstrations and the equipment they have. But again, I would say that, 90% of this software is going to be based upon open source. Now the robots, the hardware is still probably the expensive part right here, that we have to buy. These are, of course, cheaper, much cheaper than the KUKA arms. No, the KUKA guys aren't here still, are they?
Yes.
Yeah, I actually like their arms. Yeah, they're beautiful arms, but still, anyway. Okay, have I not insulted anybody else in the room yet before I finish? That's my goal right here. Okay. All right. Yeah. Anyway, this is going to end in the demonstration system, and hopefully we're on track. So anyway, to kind of summarize, I do think open source software is essential for driving continued development of medical robotics, but also other technology within our field too as well. It does require to me some programming skills, maybe more than some, probably good programming skills, I should have said right here too as well. But it does enable teams to interact with others. So, the open source software also becomes a platform for discussion and for forming groups around that too as well. So I used to have a talk that said there will be a robot in your future, but now I think we can say there will be open source in your future. So get on board if you're not already on board, and learn to embrace it. I'm probably not going to learn to program with it again, but I'll continue to hire smart young engineers who can do it. So with that, thanks for your attention, and if we have time for questions. Yeah.